Okay, so I guess we have a plan. That was much ado about nothing. Should we just start then? Okay. I think these slides are already up here, if I'm not mistaken. Yes. So I'm going to present sort of the starter slides for this. Let me get the screen sharing going. We're going to break for coffee here at the Schloss and for just a little while. I know this is a little disjoint because of the COVID test break we had to do. But this presentation should take about that long. We can come back and I think and then discuss a little bit how we do breakouts, if that makes sense, Hilda. So we'll have everybody come back here after the coffee break. Yes. What are people seeing? Not what they should be seeing. How's that? Better?
That looks good.
Yeah, we can see the presentation now.
Okay,
Yeah.
cool.
Yeah, it's fine.
So this was the topic as written in on the Confluence page, which is really looking at data structure components. And the idea behind this is that the components that we have form kind of a toolkit. That is, let me explain what that means, or I'll try. We're basically releasing the core model in the immediate term, and there's a lot of work going on to make that happen. And it's, what did I say earlier? 160 classes of different types, right? And we expect people to consume them sort of as a library. So as the basis for something specific used by a community. We talked about that earlier this morning. We're going to be releasing that core spec and then following it up with a bunch of supporting material, which includes examples, use cases, mappings, other explanatory documents about the architecture and so on. And some of that was in the public review, some of it was not. But they'll be done sort of as a major sort of core release of the specification and then a release of supporting materials. Future modeling work is going to deal with a lot of issues that we've already identified within the working group, I think. And some of those are topics here. Some of the future modeling work, though, is really going to be brought up by implementers as we move forward. And as we begin working with people, and I'll talk about examples in a minute, we begin to see certain aspects of that activity that suggest that we're missing a piece of it is implementation guidance, but it's very specific, I think, and it has to do with using the model in a consistent way to describe data of different types. And that's kind of the thinking behind this. We know there are new types of data that we're not supporting yet in DDI, CDI, and we have to figure out how best to deal with those. Implementers need, among other things, to figure out which classes in the model they're going to use. And the implementer's guide is looking at that broadly, as we discussed this morning. This topic is really looking at that with a very narrow focus, which is to say, when we're describing data, how do we know which classes to use? How do we know which are appropriate for use based on the kinds of the types of data structures available and the types of data sets available in the model? Or are we dealing with something that isn't covered or isn't covered sufficiently? And you know, basically, how does DDI, CDI describe the data sets that my community is using? If there is an existing description, it should be unambiguously clear which description you want to use for that data, which description is appropriate for it. If there's a gap, it should be clearly identifiable as a gap. And right now we have a model that can do a lot of things and describe a lot of things, but we have not documented a process by which that question can be answered unambiguously, and that's kind of the challenge here. So the main idea behind this topic at this workshop is to identify a process that users can use to identify and to make decisions about the data that they're looking at. So they take examples of their data and they are able to analyze those and determine, is this a wide data set? Is this a long data set? Is it multidimensional? Is it key value? Or one of the subtypes that are in the existing DDI, CDI model? It may not be any of those things. It may be a wholly new type that has other structural features that need to be described. if that's the case, how do you go about doing that in a way that's consistent with data description of the other types that are already supported in DDI CDI? Becomes the question. What we're looking for is a methodology for doing all of those things. So we're not looking at modeling new data sets primarily. We're looking at using the existing classes to describe data sets and then identifying the methodology you would follow in order to consistently apply the existing components to new data sets. So the new constructs in the model are not the focus of this activity as we're imagining it. They are more of an incidental product of it. And I think you'll see what I mean in a second here. So that's a list of the stuff that we have in the model currently. So we have long, wide, multidimensional, key value, and a bunch of subtypes. Now, we know this isn't comprehensive. We have run into other kinds of data. We've also run into things that might be hybrids, particularly long data sets that act a little bit like wide data sets. And that can be, we don't have a lot of clarity there on where to draw the line, to be honest. But there are examples of that. We have things like graphs and hierarchies that maybe aren't described sufficiently when the data is arranged in those formats. We've talked about doing syntax for RDF, for JSON-LD. What happens when the data's in a graph, right? And there are examples of that. You have things like CSV on the web, like DataCube, where the data itself is in a graph format. And it might be useful to have a CDI description of that. I'm not sure that that's the case, but it might be. Something we should consider. When you look at the stuff in the model that we use to describe data structures, it's primarily the things in the components package when we're talking about data structure, okay? Typically, the point where you attach to the more granular data is through the represented variable class, right? And below that, there are a whole bunch of other things in the model for describing classifications and code lists and other kinds of representations, attaching concepts. But the represented variable seems to be the point where the data comes into the picture when you're describing the structures. And that's something they all have in common. Each type of data that we recognize has a data set class and a data structure class. So we have a long data structure and a long data set, a wide data structure, a wide data set. And then they reuse a lot of the same components. Not 100% the same components, because wide, for instance, has things that long has things that wide does not, as an example. And multidimensional has a lot of stuff that are not used in other structures. But where they can be done in the same way, they are. And that consistency, I think, is important in how we describe new types of data. So that's kind of what we're looking at, is how do you take the existing model and document its use as a toolkit, first for identifying when you have new types of data, and then for describing them in a consistent way. And it's not perhaps a simple thing to do. Now, part of this is obviously going to be working to examples. And I think we have graphs, some examples of graphs, and we're looking at the sort of mapping to JSON-LD and RDF. So that's an obvious example that we might want to consider. Christian will be joining us, I think, tomorrow, is that right? And giving us a presentation on NetCDF, which is, I think, quite a popular format in some domains, but also very different than things that we've looked at in the past. And maybe we'll find out a little bit more about that. We've looked at that briefly and realized that we may not completely understand how it's constructed. But it's interesting to note that both of those examples that we're looking at combine metadata and data in the same format, essentially, which is not something that a lot of things that DDI has traditionally described do, where the data is cleanly separate from the metadata, and the two are sort of resolved into a single package. NetCDF particularly, all the metadata is on board, and I know some of the stats packages do similar things. But there are other examples that we could look at. The Helmholtz oceanography example that we've mentioned earlier, that example, the one data set we've been working from is kind of a hybrid long-wide format. And when you go to the Pangaea site where that data set is available, you can actually choose to download it as a long data set with a single set of observations. which is pretty interesting because the default presentation is as a wide data set, and neither one of them is completely obvious. So examples like that might be useful as we get into this work. I think we're free to consider whatever examples we can identify, and that people should bring forward stuff that they're familiar with from their own work. In terms of the deliverables, I think I kind of want to emphasize that the primary deliverable is the process documentation or the methodology, if you will, for doing this kind of analysis, for looking at data, identifying what kind of data it is in a CDI sense, and then if it's not something that CDI can describe, then figuring out how to fill the gap. Right? What new kind of data is it? Is it a subtype of an existing type? Is it a wholly new type? And the examples, which might be very useful in their own right, would sort of become secondary deliverables. And it's up to the group, obviously, how to package those things. But our thinking is that the primary deliverable here is that process document, is that methodology, because the complexity of CDI is something that we know we need to deal with. We've sort of talked about this in the past within the working group, but we've never really documented a clear set of rules about how you tell what something is, and how you apply the existing classes. So that's kind of what we're after here. I think that's it in terms of slides here. Indeed it is. So questions? Anyone? Anybody virtual? Laura, you have your hand up.
Hi, I was wondering if you could say a couple of words more about the relationship between this documentation and the implementation guides.
Certainly, and that's a good question. I think we have 3 topics in this workshop that are very related, one of which is the implementation guide, which is taking a look, and if you read through those slides, I think they're up on the Confluence site now, you'll see that there's this very, very broad scope for that group, looking at how a community approaches implementing CDI as part of its overall sort of fair data sharing system. Describing data is central to that, Laura, but I think we're looking at a deep dive in the current topic on specifically identifying the data with existing constructs and then how to apply those constructs to new types of data particularly. So that's a very focused look. The implementer's guide is much broader than that, and in some sense is going to hopefully complement the work out of this group. The same thing can be honestly said of the syntax implementation. We think that the output from that group would be something that feeds into the implementation, and that the implementer's guide should take that into consideration, that you're selecting which classes in the model you want to use to describe data. Yes, you're also figuring out how to implement those things and represent them in a syntax. Yes, the implementer's guide would be the higher level thing that puts those things into context. Is that a good answer, Laura?
Yeah, that's a great answer. Thank you.
Okay. Doug?
Yeah, I just wanted to ask for clarification on, I didn't quite follow. Did you say there are no existing like list of heuristics or questions that you use to discern types like long versus wide or things like that? Or is there any material that we could look at that kind of is your initial questions you ask about a data set when you're doing that?
There have been discussions about this within the working group, Doug, and I know that as we were writing the public review documentation, we did consider what those differences were. So I think the best place to start is really to go back to the public review and look at the high-level documentation and how it characterizes them. But I will say that there has been that hasn't been brought forward in any particularly clear way that I'm aware of. Dan, are you going to address that? I see your hand is up.
No, I had an unrelated question or concern.
Okay, well, let me come back to that. Does anybody else from the CDI group have a different answer for Doug? Just curious. Because we did talk about that at the point at which it was documented for the public review. I don't think it's come up again as in terms of the rules you use to distinguish between different types of data. Hilda, you're nodding. Okay.
Mostly by example, I think, in our documentation.
I think we do have a number of examples, and Larry, you might be a good person I think you have a good overview of those. But that's probably the way we've been trying to explain it to people most. Dan, you had a different question for us.
Yeah, so I have some general concerns about this whole approach, but I'll bring them up in the in the breakout session. But you mentioned graph and hierarchical data structures several times in your introductory presentation and listed the four types of structures that we have in CDI, and of course the graph hierarchy structures not among them. And I'm wondering whether that really means that this is something that we have to spend time adding to the standard before we release it, because it seems to me that this is a pretty big use case.
It was interesting. Let's take graphs as an example. I asked Flavio straight out, and he'll be joining us on Wednesday. Can we describe graphs in DDI, CDI? And he said, sure, they're just key value data structures, which is, of course, a partial answer, and he recognized that because there's more to them than that. But when you look like at NetCDF, Dan was one of the examples I gave, and hierarchical may be a bad descriptor of that, but they are arrays of arrays, and when you really look at the documentation for that format, I'm not sure it's not basically multidimensional.
Well,
maybe we already described these things, Dan. I'm not sure, honestly.
I think we have actually, and it's in the description that we ended up with around oh God, Larry, help me out. When we were meeting in Lawrence, we came up with this whole way of talking about a hierarchy. It had to do with collections.
The collections,
Right. It was
allows you
yeah.
to,
And this method could be used to describe a graph or a tree, which is a kind of graph. We've thought that through. I mean, it exists. We just need to make sure that it's tied in somehow.
Yeah, I don't know if you want to, Arfan, get into details on this right now, but I've been thinking about this some too, and especially graphs.
Okay.
And I mean, we certainly can describe the common way of representing graphs, where you have a table of nodes and a table of edges. And we have everything we need to do that. We don't have classes that actually are a node and an edge. I suppose if you wanted to go to that level, you could do that. I guess it depends on what you want to be able to do with graph data. Does that make sense?
Right. We're not looking at generically describing graphs. We're looking at use cases where the data is expressed as a graph, where that's how it's modeled. Right. And that's not a lot of what's in RDF is not data. It's metadata primarily. But we do have examples where there are data formats that are done using graphs, right? Using RDF specifically.
I have one out of the Department of Labor, so it's a use case and it's completely data.
I guess, Mike, what I'm really after here, you guys, is the documentation that lets an implementer know, when I have this kind of stuff, here's how CDI would be used, and that we can illustrate that and give them guidance, even to the extent of having rules about how you make decisions based on certain particular features of the data when you analyze it. That's why I'm sort of emphasizing the process or the methodology documentation over the model itself. I think a lot of these things we can do. Maybe there will be tweaks to the model, but I think primarily what we really want to do is make it clear to people how they should use the model. I guess that's kind of the thinking behind this topic for this week, the way we framed it up here. And so I think any of the examples and the thinking you're talking about should be brought forward, you guys. I think that's fine. I'm not sure that, you know, I don't see us putting a lot of constraints on what's brought into the discussion. I would like to see that the deliverable be along the lines that I've sort of outlined here. I guess that's the main thing. So, any other comments? Because it's coffee time for us here in person. Are we good for the moment, people? Is this a good time to take a break? Any other questions before we do?
When do we reconvene?
Hilda, when do we reconvene?